This is a standard limit that appears in calculus and has some interesting properties. Let's first see what happens if we try direct substitution. As n approaches infinity, n would become infinity, and infinity raised to the power of 1 over infinity gives us an indeterminate form. Specifically, we get infinity to the power of 0, which is indeterminate. To solve this limit, we'll use a powerful technique involving logarithms. Step 1. Let's define y as our limit. So y equals the limit as n approaches infinity of n raised to the power of 1 over n. Now, we can take the natural logarithm of both sides. Since the natural logarithm is a continuous function, we can bring the limit inside. Step 2. Let's use the properties of logarithms to simplify this expression. We know that the logarithm of a power equals the power times the logarithm. So, logarithm of n raised to 1 over n equals 1 over n times the logarithm of n. Now our expression becomes natural log of y equals the limit as n approaches infinity of 1 over n times natural log of n. Step 3. Now, let's focus on the limit of 1 over n times natural log of n as n approaches infinity. This is a well-known limit in calculus. We can solve it using L'Hopital's rule or by recognizing that as n approaches infinity, the natural log of n grows much slower than n itself. Here's a visualization to help us understand this. Let's look specifically at the ratio of natural log of n to n for various values of n. As n gets larger, this ratio gets closer and closer to 0. Therefore, the limit of natural log of n divided by n as n approaches infinity equals 0. Step 5. Now that we know the limit equals 0, let's go back to our original equation. We had natural log of y equals the limit as n approaches infinity of 1 over n times natural log of n, which we now know equals 0. So, natural log of y equals 0. To solve for y, we take e to the power of both sides. E to the power of 0 equals 1. So y equals 1. Let's verify our answer by looking at some numerical values. As n gets larger and larger, n to the power of 1 over n gets closer and closer to 1. Therefore, the limit as n approaches infinity of n raised to the power of 1 over n equals 1. This is our final answer. To summarize how we solved this problem, we first defined y as our limit, then took the natural logarithm of both sides. We simplified using logarithm properties to get natural log of y equals the limit of natural log of n over n. We recognized this limit equals 0. So natural log of y equals 0, which means y equals 1. Therefore, the limit as n approaches infinity of n to the power of 1 over n equals 1.